Oleg Strashnov is the biggest monohull heavy-lift crane vessel in the world, built exclusively for the offshore installation market. GustoMSC, a specialist in purpose-built offshore installation facilities, developed the revolutionary concept and fully designed both ship and crane from scratch. The DP3 classified Oleg Strashnov, named after one of the client company's founders, was built by Dutch maritime construction specialists. The ship is 185 meters long and 47 meters wide, with a 13-meter installation draft for stability during operation and a 6-meter transit draft for fast transit, allowing for a maximum speed of 14 knots. GustoMSC organized the design, procurement, fabrication, installation and commissioning of the fully revolving multi-million euro offshore crane. Its capacity of 5,000 tons is unprecedented for a single-body ship. In transit, the ship has to pass several bridges with very little clearance at the sides and top. To allow a safe passage, crane and bridge wings are installed at the assembly yard. The 2,400-ton fully revolving slewing platform containing the winch house is built in China and equipped and outfitted at a sub-assembly yard in Schiedam. Sheerleg Rambiz, a twin-hull lifting vessel with two 1,350-ton cranes, lifts the platform onto a barge, which will transport the load to the assembly yard. Upon arrival, the slewing platform is lifted from the barge and installed on the tub collar of the ship. An extremely precise job, leaving no room for error as the tolerance is less than a millimeter. Connecting the electrical wires that provide the crane with power up to 6.6 kilovolt ampere. The project team discusses the tight time schedule. The main lower block for 5,000 tons, weighing 160 tons itself, is hoisted aboard and put gently into the block pocket. The two lower parts of the A-frame's aft leg come into place. Because of the tight tolerances of the fittings, a perfect lineup is needed for the installation of the 850mm pin, which is installed with relatively small means. The A-frame gets hooked up with the front and aft leg already connected. As the frame needs to be rotated before it can be put into place, the slings are attached to a swivel construction. The heel point wings have guidance provisions to enable the smooth and very precise assembly of the heel point pins. Once completely in line, the shafts are pushed in very gently. Temporarily fitted hydraulic cylinders maneuver the lower leg into the mounting position. Multi-wheel transport trailers load the Y-shaped 130-meter-long boom from the quay onto a cargo barge for its trip to the assembly yard. Nothing is left to chance. Extensive manuals are made for every phase of the assembly process. Upon arrival, the boom is lifted from the barge and installed on the crane. The slimline boom is made of high tensile steel, making it lighter, stronger, more slender and easier to handle. The heel point needs to be exactly in line with its support to be able to mount the shaft. 80 ballast blocks of 12.5 tons each are lifted from a barge to the ballast box using the crane's own handling system, especially designed for this purpose. Once on board, they are sea-fastened. The ropes are reeved for all winches. The ropes for the 5,000-ton winches and the boom winch have a diameter of 64 millimeters. A series of front-runner ropes made of polyamide and steel are used to pull the main steel wire in through the reeving system. The end of the rope gets connected to the winch drum. The crane operator controls the winches for reeving in the ropes. Five tugger winches are placed in front of the crane to control the lower blocks of the hoisting system. The friction of the first windings transfers the load to the drum. The wire clamp still needs to be tightened carefully with the correct torque. After fitting the slewing platform onto the tooth rack base of the tub collar, the counter bogies with their 2x4 counter wheels are mounted, requiring some additional manpower. The counterbalance is placed near the end location and has to be skidded and lifted to the correct position. Finally, the counter bogie shaft can be mounted. With all crane components installed, the commissioning phase starts with the testing of all systems. An exciting moment arrives when the main block is lifted for the first time. Now the boom is lifted for the first time, all the way to the maximum angle of 68 degrees. Limit switches are set. One of the crane's unique features is its ability to lower the A-frame to full 13 meters, so the ship can pass relatively low bridges such as the Bosporus Bridge. After commissioning, all hoists have to be load tested, even the small ones such as the 30-ton trolley hoist and travel. Some of them are tested with water weights. All testing is monitored by the DNV surveyor in the electrical and control room. Based on the test results, all settings are optimized and the load monitoring system is calibrated. The 200-ton auxiliary 2 hoist lifts the smallest of 3 special barges filled with water to achieve the desired weight. The hookup of the largest barge for the test of 2,000 to 5,500 tons. The weight of the rigging is 130 tons. The highlight of the series of testing is Oleg Strashnov's ultimate show of force. 5,000 tons are lifted with ease. Even the overload test when the barge's weight to 5,500 tons proves no challenge for the crane. The crane can combine lifting with the main and auxiliary 1 hooks to be able to tilt jackets. Oleg Strashnov can handle large modules and put them delicately into place. Upon the completion of the final commissioning and test program, Oleg Strashnov sails to the open seas to commence her first installation project. A perfect job accomplished, with GustoMSC adding a jewel to the offshore installation fleet.